Hello, grade 10s. Today we're going to be working with word problems from the slides equations, and the slide numbers are going to be 38 to 43. So what I'm going to do is I'm going to start with example 1, and I'm just going to read it out to you. It says the sum of two numbers is 5. Their difference is 19. Determine the numbers. So we've got, with these word problems, you will have unknown values, and your unknown values in maths we normally make letters. For example, X, Y, Z. Okay, so they're saying the sum of two numbers. So what are our numbers? Well, let the first number be X. Okay, there's our first number. We don't know what it is. Let the second number be another number that is not X. So something that is different from X will be Y. So there are two numbers. And they're saying here that the sum of these two numbers is 5. So let's sum these two and set it equal to 5. They go on to say then that the difference between these two numbers is 19. So difference in maths means subtraction. So X minus Y equals 19. Now that we have two equations and two unknowns, X and Y, we can solve these simultaneously. So I'm going to work with this equation, and I'm just going to take the Y to the other side, and we get X is equal to 5 minus Y. I'll call this equation 1, and I'll call this equation 2. What we're going to do now is we are going to sub equation 1 into equation 2. So wherever I see an X in equation 2, I am going to replace it with that 5 minus Y. So this X now becomes 5 minus Y. Minus the Y equals 19. I can just get rid of these brackets. And I have a nice equation there to solve. Minus y gives me minus 2y. If I take the 5 to the other side, it becomes a minus. 19 minus 5 is 14. To get y on its own, I divide by minus 2. Divide by minus 2 on both sides. And we get y is equal to minus 7. So we have our first number. Now, in order to find our second number, I'm going to take this and I'm going to substitute it back into this equation 1. And in this equation 1, wherever I see a y, I'm now going to replace it with minus 7. And we get x is equal to 5 plus 7. So x is equal to 12. And there are our two numbers. Our first number being 12 and our second being minus 7. If we look at example 2 now. Example 2 is saying the length of a rectangle is 5 meters longer than its breadth. Calculate the length and the breadth if the perimeter is equal to 30 meters. So first of all, what I'll do here is I'll just draw up a rectangle and fill in the information. Okay, so going back to the question, they're saying that the length of a rectangle is 5 meters longer than its breadth. Well, what's the unknown here? The unknown would be the breadth, because we know that the length is 5 meters longer than that. So the breadth is always the shorter side of the rectangle. So I'm going to call that one x. That is our unknown. And they've told us that the length of the rectangle is 5 meters longer. So this length over here would be our breadth's length plus an extra 5 meters. Being a rectangle, the opposite sides are equal in length. So if that's x plus 5, this length will also be x plus 5. If this length is x, that must be x. And now to go on, they've said that the perimeter, in other words, if we add all of the lengths of the rectangle, is equal to 30. So we know that the perimeter, P, is equal to 30. So let's work out the perimeter in terms of these values that we've got here. So if I start over here, we have x plus this length, x plus 5, plus that breadth, plus that length over there. And that must all be equal to 30. Now, if we add all of these things up, we've got x plus x plus x plus x gives us 4x. 5 plus 5 gives us 10 equals 30. Nice little equation to solve. So we get 4x is equal to 20. To get x on its own, we divide by 4, divide by 4. So we get x is equal to 5. The question was, calculate the length and the breadth. Well, the breadth we said was x, and x is 5. So we know that the breadth is 5 meters. Now, to work out the length, we know that the length is x plus 5, and our x is 5. So we have 5 plus 5, which gives us 10 meters. Going on to example 3 now. Now, example 3 is a little bit tricky in terms that they've given you a lot of information to try and translate from the English into maths. So I'll read it nice and slowly for you so everyone can hear. A man is at present 9 times the age of his son. In 3 years' time, the father's age will be 5 times his son's age. What are their present ages? So first of all, I'll read the first sentence again. A man is at present 9 times the age of his son. So the unknown there is the son's age, because we know that the father's age is 9 times the son's. So if we say here, let the son's age be x, that means that the man's age will be 9x, because they've said that it is 9 times the son's age, so we get the 9x. They then go on to say in 3 years' time. So in 3 years' time, what will the son's age be? Well, in 3 years' time, the son's age will be x plus 3. What will the man's age be? In 3 years' time, it will be 9x plus 3. So those are their ages in 3 years' time. It then goes on to say that the father's age will be 5 times his son's age in these 3 years' time. So the father's age will be equal to 5 times the son's age. If I just distribute that 5 in, I get 9x plus 3 equals 5x plus 15. I now have a nice equation to solve. If I take the 5x to the other side, it becomes a minus. So 9 minus 5x would give us 4x equals 15 minus 3 gives us 12. Divide by 4 to get the x on its own, and we get x is equal to 3. So now we've got a value for our x. They are asking what are their present ages. So if we go back to what we've written up here, this is their present ages. This will be their ages in 3 years' time. These are the ones that we are interested in. So the sun's age will be equal to x. We know what x is, it's 3. So the sun is 3 years old. If we look at the man's age, at present, his age is 9x. So 9 times, we know what x is, it is 3. 9 times 3 is 27 years old. Grade 10s, I would like you to do exercise 4.10, numbers 1, 2, 3, 4, 10, and 14, please. Thank you.